There is a contradiction at the center of modern astronomy that has refused to resolve itself for nearly 75 years. The observable universe contains roughly 2 trillion galaxies. Each of those galaxies contains, on average, somewhere between 100 billion and 400 billion stars. A significant fraction of those stars host planetary systems, and a measurable percentage of those planets occupy zones where liquid water can persist on a solid surface. By every reasonable statistical estimate, life should be common, intelligence should have emerged repeatedly, and the night sky should be saturated with evidence of activity. Instead, it is quiet. No structured signals, no detectable engineering on stellar scales, no probes, no beacons, no unambiguous transmissions. This silence has a name. It is called the Fermi Paradox, and for decades it has been treated as an open scientific problem with no preferred solution. Then, beginning in 2017 and accelerating through 2023, something changed. The United States government began releasing documents, video footage, and sworn testimony describing objects in our own atmosphere that defy conventional explanation. Naval aviators, radar operators, intelligence officers, and elected officials have all placed information into the public record that points toward a possibility most scientists have refused to consider seriously. What if the paradox was never really a paradox? What if the silence above us was misread because we were looking at the wrong distance, in the wrong frequency, with the wrong assumptions about how a more advanced civilization would behave? This is not a question about belief. It is a question about evidence, classification, and the limits of human perception. Over the next several hours, the released files and the paradox they may resolve will be examined together, piece by piece, to determine whether the universe is empty or whether it has simply been quiet on purpose. The problem begins with a number, and the number is uncomfortable. When astronomers attempt to estimate how many stars exist within the observable universe, the figures arrive at scales that resist intuition. A single galaxy of average size contains roughly 100 billion stars. The Milky Way alone, by current measurements, holds somewhere between 200 billion and 400 billion stellar bodies, depending on whether brown dwarfs and remnant objects are included in the count. Beyond our galaxy lies the Local Group, and beyond that the Virgo supercluster, and beyond that the Laniakea structure, and beyond that an expanse of galaxies whose total count was revised upward in 2016 when a Hubble Deep Field analysis suggested the universe contains not the previously assumed 200 billion galaxies, but closer to 2 trillion. The arithmetic that follows is so large that it cannot be properly visualized. If every galaxy holds 100 billion stars and there are 2 trillion galaxies, the total stellar count reaches roughly 2 times 10 to the 23rd power. That is more stars in the observable universe than there are grains of sand on every beach and every desert on Earth combined, by several orders of magnitude. Around each of those stars, planets are now known to be common rather than rare. The Kepler Space Telescope, launched in 2009, transformed exoplanet science from a hypothetical field into a statistical one. Before Kepler, fewer than 400 exoplanets had been confirmed. After Kepler, the catalog expanded to thousands of confirmed worlds and tens of thousands of candidates, and the broader inference drawn from that dataset was even more significant than the catalog itself. Astronomers learned that planetary systems are not the exception, but the rule. The average star in the Milky Way has at least one planet in orbit around it, and a substantial fraction of those stars host multiple worlds. Of particular interest are the planets that occupy what astronomers call the habitable zone, sometimes informally referred to as the Goldilocks region, where the distance from the parent star allows surface temperatures compatible with liquid water. Current estimates suggest that the Milky Way alone contains somewhere between 300 million and several billion potentially habitable planets, with the precise figure depending on how habitability is defined. When those numbers are extrapolated across the full count of galaxies in the observable universe, the result becomes nearly absurd. The possible habitable worlds run into the sextillions. Even if life requires an extraordinarily rare combination of chemistry, geology, and stellar stability. The sheer scale of the available planetary real estate seems to guarantee that biology should have emerged somewhere other than Earth. And once biology emerges, evolutionary pressures suggest that complex life, and eventually intelligent life, should also appear given sufficient time. Our universe is approximately 13.8 billion years old. The Earth is roughly 4.5 billion years old. Life on Earth appeared within a few 100 million years of the planet cooling enough to support it. Intelligence followed, technological civilization followed that, and radio communication emerged within the last 130 years. If the timeline that produced humanity is reasonably typical, then countless other worlds across cosmic history should have followed similar timelines, and many of them would have reached technological capability long before our solar system even existed. This is where the silence becomes confrontational. If life is common, and if intelligence is a natural consequence of life given enough time, and if technological civilizations have had billions of years to develop, then the universe should contain abundant evidence of their presence. Radio transmissions should be detectable. Engineered structures should be visible. The infrared signatures of stellar-scale construction projects, sometimes called Dyson spheres or Dyson swarms, should be identifiable across galactic distances. Probes should have arrived in our solar system long ago, since even at a fraction of the speed of light, a self-replicating probe network could colonize an entire galaxy in a few million years, which is a blink in cosmic time. And yet, when astronomers point their instruments at the sky and search systematically, they find nothing. No artificial signals, no engineered light curves, no techno-signatures of any kind that survive scrutiny. The sky is, by every measurable standard, empty. The contradiction was first articulated formally in 1950 during a lunchtime conversation at the Los Alamos National Laboratory. The Italian physicist Enrico Fermi, working alongside colleagues Edward Teller, Emil Konopinski, and Herbert York, was discussing a cartoon in The New Yorker that depicted aliens stealing trash cans in New York. The conversation drifted toward the plausibility of interstellar travel and the apparent absence of visitors from other worlds. At some point during the discussion, Fermi turned to his companions and asked a question that has echoed through astrophysics ever since. The exact wording varies across recollections, but the substance was simple and devastating. Where is everybody? The question landed with weight because Fermi was not a casual speculator. He was one of the most accomplished physicists of the 20th century, a Nobel laureate whose calculations had been central to the development of nuclear fission. When he asked where everybody was, he was performing a back-of-the-envelope estimate in his head, comparing the expected density of advanced civilizations to the observed evidence, and noting that the two numbers did not match. That mismatch is the heart of what would later be called the Fermi Paradox, though the formal name was not applied until decades later. The paradox can be stated in a single sentence. The probability of extraterrestrial civilizations existing appears to be very high, but the observed evidence of their existence is effectively zero. Something in that equation must be wrong. Either the probability is being overestimated, or the evidence is being underestimated, or there is a mechanism that systematically prevents the two from meeting. Each of these possibilities leads to a different and equally unsettling conclusion. If the probability is wrong, then life or intelligence is far rarer than we believed, and humanity may be functionally alone in a vast empty cosmos. If the evidence is wrong, then we are missing something that should be visible, either because our instruments are inadequate or because we have not looked in the right way. And if a mechanism prevents the two from meeting, then there is a process operating in the universe that we do not yet understand. And that process may have implications for our own future. For most of the 20th century, the paradox was treated as an academic curiosity. Astronomers acknowledged it, discussed it at conferences, and occasionally published papers exploring possible resolutions, but it remained on the margins of serious science. The reason was practical. There was no data. Without observations of either extraterrestrial civilizations or their absence at meaningful statistical scales, the paradox could not be addressed empirically. It was a thought experiment, not a research program. That began to change in the 1960s with the launch of the first systematic radio searches for extraterrestrial intelligence, and it changed more dramatically in the 1990s with the discovery of the first confirmed exoplanets. As the data improved, the paradox sharpened. Each new exoplanet detection, each new estimate of habitable worlds, each new null result from radio searches, all of these pushed the contradiction further into the open. By the early 21st century, the paradox had become impossible to ignore. The numbers were too large, the silence was too complete, and the possible explanations were too consequential to leave unexamined. Researchers began categorizing the possible solutions into broad families. There were rare Earth hypotheses, suggesting that the specific conditions producing intelligent life on Earth were so improbable that they had not been replicated elsewhere. There were great filter hypotheses, suggesting that some evolutionary or technological barrier prevents life from progressing past a certain stage. There were communication hypotheses, suggesting that advanced civilizations communicate in ways we cannot detect. And there were concealment hypotheses, suggesting that the evidence of other civilizations exists, but is being deliberately hidden, either by those civilizations themselves or by entities within our own institutions who possess that evidence and have chosen not to share it. Each of these families generated sub-hypotheses, and each sub-hypothesis generated arguments and counter-arguments, and the literature grew dense and inconclusive. Then, in the second decade of the 21st century, something shifted. A small number of military and intelligence personnel began speaking publicly about classified programs that had been collecting data on anomalous aerial phenomena for decades. The data described objects that appeared to violate known physics, that were observed simultaneously by multiple independent sensor systems, and that had been the subject of internal government reports never intended for public release. This information did not arrive as a single revelation. It emerged gradually, in fragments, through investigative journalism, congressional testimony, and the slow declassification of documents that had been buried in archives. As each fragment surfaced, a new question began to form. If the Fermi Paradox describes a silent universe, what does it mean when the universe is not actually silent, but only being reported as silent because the evidence is held in classified storage? But one question remains unanswered. What exactly was Enrico Fermi thinking when he asked where everybody was, and how did his question evolve from a lunchtime remark into the most persistent, unresolved problem in modern science? To understand the weight of Fermi's question, the man asking it must be understood first. Enrico Fermi was born in Rome in 1901, and by the age of 17, he was already conducting independent research in theoretical physics. He was the kind of mind that produced order from chaos through sheer computational instinct. Colleagues described him as the last physicist who was equally exceptional at both theory and experiment, a rare combination in a discipline that increasingly demanded specialization. He won the Nobel Prize in 1938 for his work on induced radioactivity, and within a few years, he was leading the team that produced the first self-sustaining nuclear chain reaction beneath the bleachers of Stagg Field at the University of Chicago. He had a particular reputation for what came to be called Fermi problems, a kind of mental estimation technique in which complex quantitative questions were broken down into rough orders of magnitude and solved without instruments. The classic example involved estimating the number of piano tuners in Chicago using only general assumptions about population, household instruments, and tuning frequency. The point of the exercise was not precision, but discipline. By making explicit assumptions and chaining them together logically, even questions that seemed unanswerable could yield useful approximations. When Fermi asked where everybody was during that summer lunch in 1950, he was not making a casual remark. He was performing a Fermi problem in his head, and the result disturbed him enough to voice it aloud. The recollections of his companions, recorded in interviews decades later, suggest that the conversation had been wide-ranging. Edward Teller remembered discussing the recent wave of flying saucer sightings that had been reported in American newspapers throughout the late 1940s. The cartoon in The New Yorker that supposedly triggered the question depicted aliens emerging from a spacecraft to steal city trash cans, a visual joke that fit the cultural mood of the period. The Kenneth Arnold sighting of 1947 had introduced the term flying saucer into the popular vocabulary, and the Roswell incident had occurred just 2 weeks later, generating its own newspaper coverage before the official military explanation shifted from recovered disk to weather balloon. By the time Fermi was eating lunch with his colleagues 3 years later, the topic of unidentified aerial objects was already part of public discourse, though serious scientists generally treated it with skepticism. What made Fermi's question different from the dismissive attitude of most of his peers was that he took the underlying mathematics seriously. The galaxy contains hundreds of billions of stars. Even if only a small fraction of those stars host planets, and only a small fraction of those planets are capable of supporting life, the absolute number of potentially inhabited worlds is still enormous. Furthermore, the galaxy is old. The Milky Way is approximately 13 billion years old, and most of its stars formed billions of years before the Sun. This means that any civilization developing in our galaxy at a typical pace would have had vastly more time than humanity has had to develop technology, including the technology required for interstellar travel. Fermi knew that even at speeds far below the speed of light, a civilization could colonize the entire galaxy in a few million years using a wave of slow probes or generation ships. A few million years is essentially nothing compared to the age of the galaxy. So if technological civilizations had emerged repeatedly throughout cosmic history, evidence of their expansion should be everywhere. And yet, by all available evidence, no such expansion had occurred. The question was not whether aliens existed in principle. The question was why their absence was so total and so absolute. This is the structural form of what would later be called the Fermi Paradox, though the formal terminology was not introduced until 1975, when the astronomer Michael Hart published a paper titled "An Explanation for the Absence of Extraterrestrials on Earth." Hart took Fermi's informal question and developed it into a rigorous argument. He pointed out that the galaxy could have been colonized many times over by now, given the timescales involved, and that the absence of any colonizers required explanation. Hart proposed several possible solutions, including physical impossibility of interstellar travel, sociological factors that prevent expansion, and the possibility that humanity is simply the first technological civilization in the galaxy. His paper formalized the discussion and made it citable in the scientific literature, transforming a lunchtime remark into a recognized problem in astrobiology. A few years later, in 1980, the physicist Frank Tipler extended Hart's argument with a paper of his own, focusing specifically on the implications of self-replicating machines. Tipler argued that any sufficiently advanced civilization would inevitably build self-replicating probes, sometimes called von Neumann probes, after the mathematician John von Neumann, who first explored the concept in the 1940s. Such probes would be designed to travel to other star systems, mine raw materials, build copies of themselves, and continue spreading outward. Starting from a single civilization, a fleet of these machines could fill an entire galaxy in a time frame that, while long by human standards, is short compared to the age of the universe. The fact that no such probes have been detected in our solar system, Tipler argued, suggested either that no other civilizations exist or that something prevents them from building such machines. His conclusion was that humanity is alone, at least within our galaxy. This conclusion was vigorously contested by other researchers, most notably Carl Sagan, who argued that Tipler had underestimated the difficulty of building self-replicating probes and overestimated the willingness of civilizations to build them, even if they were technically possible. Sagan suggested that the absence of probes might simply reflect the practical and ethical constraints faced by mature civilizations, rather than the absence of civilizations entirely. The debate between the rare or absent intelligence position and the abundant but quiet position has continued ever since, with new evidence and new arguments being introduced on both sides regularly. What made the paradox especially difficult to resolve was the asymmetry between presence and absence. To prove that extraterrestrial civilizations exist, only a single confirmed example is required. One unambiguous signal, one verified artifact, one direct contact, and the question is settled. But to prove that they do not exist, every possible hiding place must be eliminated, every possible communication method must be monitored, every possible mode of existence must be ruled out. This is functionally impossible. The best that can be done is to survey larger and larger volumes of space, scan wider and wider frequency ranges, and slowly reduce the probability of intelligent life existing within certain detection thresholds. Each null result narrows the parameter space slightly, but never eliminates it entirely. After more than 60 years of systematic searching, the parameter space remains large enough that confident statements about the absence of extraterrestrial intelligence are scientifically unjustified. The silence is real, but the silence does not prove emptiness. What it does prove is that something is producing the gap between expectation and observation. That something has been the central question of the paradox for 7 decades, and the proposed answers fall into roughly 3 categories. The first category includes solutions that revise the expectation downward. Perhaps life is rarer than we assume. Perhaps intelligence is rarer still. Perhaps technological civilization is so improbable that even across 2 trillion galaxies, only a handful exist, and they are too far apart to detect each other. The second category includes solutions that revise the observation upward. Perhaps civilizations exist in abundance, but they communicate in ways we cannot intercept, or they exist on timescales that do not align with ours, or they have transitioned to forms of being that are simply invisible to our current instruments. The third category, which has historically been the most controversial, includes solutions that suggest the silence is artificial. Perhaps civilizations exist nearby, perhaps even within our own solar system, but they are deliberately concealing themselves, either to protect themselves from detection or to avoid disrupting the natural development of younger species like our own. This third category was, for most of the 20th century, dismissed by mainstream science as unscientific speculation. It was associated with fringe ideas about flying saucers, government cover-ups, and conspiracy theories that lacked credible evidence. Respectable researchers avoided it, partly because they did not want to be associated with the more outlandish claims circulating in popular culture, and partly because there was no rigorous data to evaluate. The third category required taking seriously the possibility that some of the unidentified objects reported by pilots, sailors, and civilians might actually be evidence of non-human technology operating in our atmosphere. Without instrumented data, controlled observations, or verified physical evidence, this possibility could not be evaluated scientifically. It was, at best, a hypothesis waiting for evidence that did not seem to be forthcoming. That changed when military and intelligence communities began acknowledging that they had been collecting exactly the kind of data that would be required to evaluate the third category. The acknowledgement did not arrive all at once. It came in pieces over years through journalistic investigation, congressional pressure, and the gradual release of documents that had been classified for decades. Each piece, taken individually, could be dismissed or contextualized. But taken together, the cumulative weight of the disclosures began to shift the conversation in ways that would have been unthinkable a generation earlier. Yet this evidence raises new scientific questions, and to understand what those questions are, the formal mathematical framework that has shaped the modern discussion of extraterrestrial intelligence must be examined directly. In 1961, a young radio astronomer named Frank Drake faced a practical problem. He had been invited to organize a small conference at the Green Bank Observatory in West Virginia, where the United States National Academy of Sciences had agreed to convene a meeting of researchers interested in the scientific search for extraterrestrial intelligence. The conference was unusual for its time. The very idea that searching for intelligent life elsewhere in the universe was a legitimate scientific activity remained controversial, and Drake had to construct an agenda that would give the participants something concrete to discuss. He needed a framework that would organize the conversation, identify the relevant variables, and produce something resembling a quantitative estimate of how many communicating civilizations might exist in the Milky Way at any given moment. He wrote down his framework on a chalkboard in the conference room, and what he wrote has become one of the most discussed equations in the history of modern astronomy. The Drake equation, as it came to be known, is not really an equation in the mathematical sense. It is a chain of multiplications that combines 7 distinct factors into a single estimated number. The first factor is the rate at which stars form in our galaxy, measured in stars per year. The second factor is the fraction of those stars that have planetary systems. The third factor is the average number of planets per star that lie within the habitable zone where liquid water can exist. The fourth factor is the fraction of those habitable planets on which life actually arises. The fifth factor is the fraction of those living planets where intelligence eventually evolves. The sixth factor is the fraction of intelligent species that develop technology capable of releasing detectable signals into space. The seventh factor is the length of time, in years, that such technological civilizations remain detectable before either falling silent or disappearing entirely. When all 7 factors are multiplied together, the result is an estimate of how many detectable civilizations should exist in the Milky Way right now. The problem with the Drake equation is also its genius. The first 3 factors can be measured with reasonable confidence using modern astronomy. The star formation rate of the Milky Way is known to be approximately 1 to 3 solar masses per year. The fraction of stars with planetary systems was estimated speculatively in 1961, but after Kepler, we now know that essentially all stars have planets, so this factor approaches 1. The number of habitable zone planets per star is also reasonably well constrained, with current estimates suggesting that roughly 20 to 50% of Sun-like stars host at least one rocky planet in the habitable zone. These 3 factors alone produce a substantial number of potentially habitable worlds, on the order of billions across the galaxy. The remaining 4 factors are where the equation collapses into uncertainty. The probability that life arises on a habitable planet is unknown. It might be 1, meaning that life inevitably emerges whenever the chemistry permits it, or it might be 1 in a trillion, meaning that Earth is an extraordinary outlier and most habitable planets remain sterile. The probability that life, once established, evolves into intelligence is also unknown. On Earth, life existed for roughly 3.5 billion years before complex multicellular organisms appeared, and another 500 million years passed before any species achieved the cognitive capacity for tool use, language, and abstract reasoning. Whether this trajectory is typical or exceptional cannot be determined from a single example. The probability that intelligent species develop detectable technology is similarly uncertain. Many intelligent species on Earth, including dolphins, elephants, and various primates, have never produced radio transmitters or interstellar probes. Whether technological development is a natural consequence of intelligence or a peculiar accident of human history remains an open question. And the final factor, the lifespan of a technological civilization, is perhaps the most troubling of all. Humanity has been transmitting detectable signals for roughly 130 years. Whether civilizations typically last for thousands, millions, or only a few hundred years cannot be known until we have examples to compare. Because 4 of the 7 factors are essentially unknown, the Drake equation produces wildly different answers depending on the assumptions plugged into it. Optimistic estimates yield numbers in the tens of thousands or even millions of communicating civilizations within the Milky Way. Pessimistic estimates yield numbers less than 1, suggesting that even our own existence is statistically improbable and that we may be the only technological species in our galaxy. The equation, in other words, does not solve the Fermi Paradox, it quantifies it. By making the uncertainty explicit, it shows precisely where our ignorance lies and what would be required to reduce it. Despite these limitations, the Drake equation has remained a central organizing tool for astrobiology for more than 60 years. It has shaped the design of search programs, influenced the allocation of telescope time, and provided a vocabulary for discussing extraterrestrial life that is both rigorous and accessible. Every advance in exoplanet science, Every refinement of our understanding of planetary habitability, every new constraint on the chemistry of early Earth contributes to narrowing one of the equation's factors. Each time a factor is constrained, the range of possible answers narrows slightly and the paradox sharpens. The more we learn about the prevalence of habitable worlds, the more difficult it becomes to explain the silence using the rare planet argument. The remaining uncertainty shifts onto the biological, evolutionary, and sociological factors, which are far harder to study from a distance. In 1961, when Drake wrote his equation on the chalkboard, the participants at the Green Bank Conference attempted to assign values to each factor and arrived at an estimate of somewhere between 1,000 and 100 million communicating civilizations in the Milky Way. The range was so wide that it could not be considered a prediction in any meaningful sense, but the exercise made clear that even under conservative assumptions, the galaxy should not be empty. Among the conference attendees was a young Carl Sagan, who would go on to become one of the most prominent advocates for the scientific search for extraterrestrial intelligence. There was also Philip Morrison, the physicist who had co-authored the seminal 1959 paper proposing that radio frequencies near the 21-centimeter hydrogen line would be ideal for interstellar communication. The conference was small, with only about a dozen attendees, but its influence on subsequent decades of research was substantial. In the years following the Green Bank meeting, several refinements and alternatives to the Drake equation were proposed. Some researchers suggested adding additional factors, such as the probability that a civilization survives its own technological adolescence without self-destruction, or the probability that it develops the will and resources to communicate across interstellar distances. Others proposed reformulating the equation to account for the spatial distribution of civilizations rather than just their total number, since two civilizations on opposite sides of a galaxy may have no reasonable means of detecting each other, even if both are actively transmitting. A particularly influential modification came in 2019, when researchers Anders Sandberg, Eric Drexler, and Toby Ord published a paper applying Bayesian statistical methods to the equation. Rather than plugging single-point estimates into each factor, they used probability distributions reflecting the full range of plausible values. Their analysis suggested that under reasonable distributions of uncertainty, the most likely outcome is that humanity is alone in the observable universe. This conclusion, often referred to as the Sandberg result, was controversial when it appeared and remains contested today, but it illustrates how the same equation can produce radically different conclusions depending on how the uncertainty is handled. While the Drake equation was being refined and debated, observational efforts to search for extraterrestrial signals were also expanding. The first systematic search, known as Project Ozma, was conducted by Drake himself in 1960 at the Green Bank Observatory, using a 26-meter dish to scan two nearby stars, Tau Ceti and Epsilon Eridani, for artificial radio transmissions. Project Ozma found nothing, but it established a template that would be followed by dozens of subsequent search programs over the following decades. The SETI Institute, founded in 1984, became the most prominent organization dedicated to this work, conducting both targeted searches of specific star systems and broader sky surveys looking for unusual signal patterns. The Allen Telescope Array, funded in part by the Microsoft co-founder Paul Allen, expanded these capabilities significantly. Despite all of this effort, no confirmed signal has ever been detected. There have been a handful of intriguing anomalies, including the famous WOW signal of 1977, which was a strong narrowband radio signal recorded by the Big Ear Telescope at Ohio State University. The signal lasted for 72 seconds, was never repeated, and remains unexplained to this day. But a single unexplained event, no matter how suggestive, cannot serve as proof of anything. It is data without context, an observation without confirmation. The cumulative null result of 6 decades of searching has had a paradoxical effect on the scientific community. Some researchers have concluded that the silence is itself meaningful evidence, suggesting that intelligent civilizations are rarer than we hoped, or that they communicate in ways we cannot detect, or that they have no interest in transmitting signals at all. Others have argued that we have barely begun to search, that the volume of space and frequency range we have examined is a vanishingly small fraction of the total parameter space, and that the absence of detected signals so far tells us almost nothing about what might exist beyond our current detection capabilities. Both views have merit, and both reflect legitimate scientific reasoning. The truth, whatever it turns out to be, will probably involve elements of both perspectives. What the Drake equation and the SETI efforts together demonstrate is that the question of extraterrestrial intelligence is not just a question for astronomers. It is a question that involves biology, chemistry, geology, evolutionary theory, sociology, and even psychology. To estimate the prevalence of intelligent civilizations, we must understand how often life arises, how often it becomes complex, how often complexity leads to intelligence, how often intelligence produces technology, and how often technology survives long enough to be detectable. Each of these questions requires its own body of research, and each remains substantially unresolved. The equation, in this sense, is less a tool for prediction and more a roadmap for what we do not yet know. But the roadmap also points to another consideration that the Drake equation does not explicitly address. If technological civilizations are common but short-lived, the galaxy might be filled with the ruins of dead civilizations rather than active ones. If they are rare but long-lived, there might be only a handful, but they might have had ample time to expand throughout the galaxy. If they are common and long-lived, the silence becomes impossible to explain without invoking some additional mechanism. This third possibility, common and long, lived but undetected, is the version of the paradox that demands the most explanation. It is also the version that has driven researchers to propose increasingly creative solutions, including one particular hypothesis that may be the most consequential idea in modern astrobiology. As one possibility fades, another emerges. The hypothesis suggests that civilizations do not simply fail to develop or fail to communicate, but that they encounter a barrier that systematically prevents them from reaching a stage where they can be detected at all. That barrier has a name. It is called the Great Filter. The Great Filter is an idea that arrived not from astronomy, but from economics. In 1998, an economist and futurist named Robin Hanson, working at George Mason University, published an essay attempting to reconcile the silence of the universe with the apparent ease of biological evolution. Hanson approached the problem with the analytical tools of his discipline, treating the development of an interstellar civilization as a sequence of probabilistic steps and asking what the data might reveal about where the bottlenecks lie. The essay was not published in a peer-reviewed journal initially, but rather appeared on Hanson's personal website, and from there, it spread through the academic and intellectual communities until it became one of the most discussed frameworks for thinking about the Fermi Paradox. The core insight of the Great Filter is straightforward. For a civilization to become detectable across interstellar distances, it must pass through a series of evolutionary and technological stages. Life must emerge from non-living chemistry. Simple cells must become complex cells. Complex cells must aggregate into multicellular organisms. Multicellular organisms must develop nervous systems sophisticated enough to support intelligence. Intelligent species must develop tool use, language, and cumulative culture. Cumulative culture must produce science, and science must produce technology capable of releasing detectable signals into space. Each of these transitions can be thought of as a step, and each step has some probability of occurring on any given habitable planet. The total probability of reaching the final stage is the product of the probabilities of each individual step. If even one step has an extremely low probability, the overall probability of producing a detectable civilization becomes vanishingly small, regardless of how many habitable planets exist. Hanson called this aggregate probability the Great Filter, and he framed the central question of astrobiology in terms of where the filter lies. There are essentially two possibilities. Either the filter is behind us, meaning that the difficult steps have already been passed by humanity and we are among the rare survivors that have made it through, or the filter is ahead of us, meaning that the most difficult steps still lie in our future. and we are on the brink of encountering whatever catastrophe has eliminated all the civilizations that should have preceded us. Each possibility has profoundly different implications. If the filter is behind us, then humanity is exceptional. The silence of the universe is explained by our rarity, and our future is open. If the filter is ahead of us, then humanity is typical. The silence of the universe is explained by the fact that all civilizations eventually destroy themselves before becoming detectable, and our prospects for long-term survival are grim. The placement of the filter is not an idle question. It connects directly to questions about our own future. If we discover that life arises readily on other planets, we have ruled out the possibility that abiogenesis is the great filter, which means the filter must lie at some later stage. If we discover that microbial life is common, but complex multicellular life is rare, we have located one possible filter and can begin to assess whether we have passed it. If we discover the ruins of dead civilizations on other worlds, we have strong evidence that the filter lies near our current developmental stage, which would be a deeply troubling finding for the long-term survival of any technological species. This is why the search for life on Mars, Europa, Enceladus, and Titan is so consequential. If those worlds turn out to harbor microbial life, even fossilized microbial life, it would suggest that abiogenesis is not particularly difficult, and that the great filter must lie somewhere later in the developmental sequence. If those worlds turn out to be completely sterile, despite having conditions that should be capable of supporting microbial life, it might suggest that abiogenesis is the filter and that we have already passed it. The current scientific consensus is that life probably exists or has existed elsewhere in our solar system, but no confirmed evidence has yet been obtained. The Perseverance rover on Mars is actively searching for biosignatures in ancient lakebed sediments, and missions to the icy moons of Jupiter and Saturn are being planned to investigate their subsurface oceans. Within the next 2 to 3 decades, we may have the first concrete data on the prevalence of life beyond Earth. In the meantime, the placement of the great filter must be reasoned about indirectly. Hansen himself argued that the filter is most likely to lie at one of several specific stages. The transition from prokaryotic cells to eukaryotic cells, which on Earth required nearly 2 billion years and appears to have occurred only once in the history of life, is a strong candidate. The development of multicellularity, which appears to have arisen multiple times independently on Earth but produced complex large-bodied organisms only relatively recently, is another candidate. The emergence of high intelligence, language, and cumulative culture is yet another candidate. And the survival of a technological civilization through the dangers of its own technological adolescence, including nuclear weapons, environmental degradation, engineered pathogens, and the unknown risks of more advanced technologies, is perhaps the most worrying candidate of all. The reason this last candidate is so worrying is that it places the filter in our immediate future rather than our distant past. Humanity has had nuclear weapons for less than a century, and we have come close to using them in anger on several occasions. The Cuban Missile Crisis of 1962 brought the world within hours of nuclear war. The Able Archer exercise of 1983 nearly triggered a Soviet preemptive strike when the Kremlin misinterpreted a NATO training operation as preparation for a real attack. The Stanislav Petrov incident of 1983 involved a single Soviet officer choosing not to report what appeared to be incoming American missiles, on the grounds that the radar warning was probably a false alarm. He was right, and his decision likely prevented a retaliatory strike that would have escalated into full nuclear exchange. The fact that humanity has survived its nuclear age so far is not necessarily evidence that we will continue to survive it. The technology persists, the political tensions persist, and the possibility of accidental or deliberate use remains real. Beyond nuclear weapons, other existential risks have entered the conversation. The development of advanced artificial intelligence raises questions about whether machine systems might pursue goals incompatible with human survival. The progress of synthetic biology raises questions about whether engineered pathogens might be deployed accidentally or intentionally. Climate change raises questions about whether industrial civilization is compatible with the planetary conditions that allowed it to develop. Nanotechnology, geoengineering, and various other emerging fields each carry their own risks, some of which are well understood and others of which remain speculative. If the Great Filter is the inability of technological civilizations to survive their own technological capabilities, then humanity is currently passing through the filter and the outcome remains uncertain. Some researchers have argued that the discovery of extraterrestrial life would be deeply ambiguous evidence regarding the Great Filter. If we found microbial life on Mars, for example, it would tell us that abiogenesis is easy, but would say nothing about whether the filter lies at multicellularity, intelligence, or technological survival. If we found a dead civilization on a nearby exoplanet, the location of its extinction would tell us where the filter is, but it would tell us by demonstrating that the filter is real and active. The optimistic finding would be that we are alone in a galaxy full of habitable but empty worlds, suggesting that the filter is behind us and that the difficult evolutionary steps have already been passed. The pessimistic finding would be that we are surrounded by ruins, suggesting that the filter is ahead of us and that civilizations like ours typically do not survive long enough to spread between stars. There is, however, a third possibility that Hansen's original framework does not fully address. Perhaps the filter is not a barrier that eliminates civilizations entirely, but a transition that transforms them into forms we cannot recognize. A sufficiently advanced civilization might upload its consciousness into computational substrates that consume negligible energy and produce no detectable signals. It might transition into virtual realities that are more interesting than physical exploration. It might develop forms of communication, transportation, or organization that simply do not involve the kinds of large-scale engineering projects we would expect to detect. The silence of the universe, in this view, is not the silence of death, but the silence of a transition we have not yet imagined. The civilizations that should have filled the galaxy are still here, but they are doing things that do not produce the technosignatures we are looking for. This alternative framing has its own complications. If advanced civilizations transition into undetectable forms, the question becomes why they would do so universally. There should be at least some civilizations at some stage of development that engage in detectable activities. The prediction of universal silence requires not just that some civilizations choose to be quiet, but that essentially all of them do, which is a strong claim about the convergent behavior of independent intelligent species. This is one reason why the Great Filter framework, in its various forms, has remained influential. It explains the silence not through choice, but through inevitability. Civilizations are silent because they cannot help being silent. Either they never reached detectability, or they did not survive long enough to maintain it, or they encountered some barrier that we have not yet identified. The Great Filter also raises uncomfortable questions about the relationship between intelligence and survival. There is no guarantee that intelligence is adaptive in the long run. On Earth, intelligence has been spectacularly successful for the species that possess it, but only for relatively brief periods of evolutionary time. Human civilization has existed for approximately 10,000 years, technological civilization for a few centuries, and globally networked industrial civilization for a few decades. Whether any of these will persist for thousands or millions of years remains unknown. If intelligence is a short-term strategy that tends to destroy its possessors, then the Great Filter may simply be the natural consequence of how intelligence works rather than any specific external threat. There is one final aspect of the Great Filter that deserves attention. Even if we cannot determine its location through current evidence, we can think probabilistically about what kinds of evidence would shift our beliefs. The discovery of extraterrestrial life, especially complex extraterrestrial life, would dramatically affect our estimate of where the filter lies. The discovery of artifacts from extinct civilizations would do the same, with implications that lean strongly toward the filter being ahead of us. The detection of active extraterrestrial civilizations would, paradoxically, be the most reassuring finding of all, because it would demonstrate that civilizations can pass through whatever filters exist and survive long enough to be detected. And the discovery that our own planet has been observed by such civilizations, perhaps for a very long time, would suggest that the silence we have been measuring is not the silence of an empty universe, but the silence of an inhabited one whose other inhabitants have chosen not to broadcast their presence in the channels we have been monitoring. Yet, this evidence raises new scientific questions, because if such observation has been occurring, then the records of those observations should exist somewhere, and the search for them should be possible not by pointing telescopes outward, but by examining what our own institutions have collected from within our own atmosphere. The first systematic effort to do exactly that began long before most modern researchers were born, and it ran for nearly 2 decades under the supervision of the United States Air Force. On June 24th of 1947, a private pilot named Kenneth Arnold was flying his small Call-Air aircraft near Mount Rainier in Washington state when he observed 9 bright objects moving in formation at what he estimated to be exceptional speed. Arnold was an experienced aviator and a credible witness. He had been searching for the wreckage of a downed Marine Corps transport aircraft when the objects appeared in his field of view, traveling in a chain-like configuration between Mount Rainier and Mount Adams. He timed their passage between the 2 peaks using the clock in his cockpit and calculated that they must be traveling at over 1,200 miles per hour, which was faster than any known aircraft of the period. When he landed, Arnold reported his sighting to local authorities, and within days the story had been picked up by newspapers across the country. In his interview with reporters, Arnold described the motion of the objects as resembling saucers skipping across water, and the press, with characteristic enthusiasm for vivid imagery, condensed his description into the phrase flying saucers. The term entered the American vocabulary almost immediately and would define popular discussion of unidentified aerial phenomena for the following decades. The Arnold sighting was not an isolated event. Within weeks of his report, hundreds of similar sightings were being filed across the United States. Some were almost certainly misidentifications of conventional aircraft, weather balloons, atmospheric phenomena, or astronomical objects. Others were harder to explain. A few were reported by trained observers using calibrated instruments, including military radar operators and commercial airline pilots. The volume and credibility of these reports created a problem for the United States Army Air Forces, which was in the process of being reorganized into the independent United States Air Force at almost exactly the same time. If the objects being reported were Soviet aircraft of an unknown advanced type, the implications for national security were severe. If they were natural phenomena being misidentified, public concern needed to be addressed through systematic investigation. And if they were something else entirely, that possibility could not be ruled out without examining the evidence directly. The Air Force responded by establishing a formal investigation program. The first iteration, called Project Sign, began operations in 1948 and was based at Wright-Patterson Air Force Base in Ohio. Project Sign was tasked with collecting and analyzing reports of unidentified flying objects, evaluating whether they represented a threat to national security, and determining their probable origin. The team assembled for the project included intelligence officers, technical analysts, and consultants from various scientific disciplines. They examined hundreds of cases over the following year, and their internal conclusions were eventually summarized in a classified document known as the Estimate of the Situation. The contents of that document have never been fully released, but according to multiple accounts from former personnel, including the testimony of Captain Edward Ruppold, who would later head a subsequent program, the estimate concluded that the most likely explanation for the unexplained sightings was that they represented craft of extraterrestrial origin. The document was reportedly rejected by senior Air Force leadership, who returned it for revision with instructions to reach more conservative conclusions. Project Sign was succeeded by Project Grudge, which operated from 1949 to 1951. Grudge took a notably different approach. Rather than seriously investigating the phenomenon, the program appears to have been designed primarily to dismiss reports and reassure the public. Cases were closed quickly, often with explanations that did not fit the underlying observations. The morale of investigators reportedly declined as they felt they were being asked to produce predetermined conclusions rather than analyze the evidence. By 1951, the program had become a target of internal criticism and a reorganization was ordered. The reorganized program became Project Blue Book, which would run from 1952 to 1969 and would become the most extensive and well-known of the official investigations. Captain Edward Ruppelt was the program's first director, and he brought a more rigorous methodology to the work. He introduced the term unidentified flying object, which he preferred to flying saucer, because it did not presuppose a particular shape or origin. He established standardized procedures for collecting and evaluating reports, and he worked to ensure that investigations followed the evidence rather than predetermined conclusions. Under Ruppelt's leadership, Blue Book accumulated a substantial database of cases, including some that the program could not explain through conventional means. The total caseload of Project Blue Book, accumulated over its 17-year history, exceeded 12,000 reports. Of these, the program officially classified roughly 700 as unidentified, meaning that even after thorough investigation, no satisfactory explanation could be found. The 700 unidentified cases were the smallest category in absolute terms, but they were also the most interesting category in scientific terms because they were the cases that resisted the standard explanations of misperception, hoax, or natural phenomenon. They were the residue that remained after every conventional possibility had been examined and rejected. Among the most discussed cases in the Blue Book archive is the 1952 Washington Flap, a sequence of incidents in July of that year in which radar operators at multiple facilities in the Washington, D.C. area, including National Airport and Andrews Air Force Base, tracked unidentified objects in restricted airspace over the United States Capitol. The objects were observed visually by airline pilots and military aviators who were sent to intercept them, but the objects accelerated away whenever intercept aircraft approached. The events occurred on 2 consecutive weekends, generated extensive press coverage, and prompted the Air Force to hold what at the time was the largest press conference since the end of World War II. The official explanation offered was that the radar returns had been caused by temperature inversions producing atmospheric refraction effects. Critics of this explanation, including some of the radar operators who had been present, argued that the inversion hypothesis did not adequately account for the consistency of the tracks, the visual confirmations from pilots, or the coordinated maneuvers of the objects across multiple radar stations. Another notable Blue Book case occurred in 1967 at Malmstrom Air Force Base in Montana. According to the testimony of multiple Air Force personnel, including former missile launch officer Robert Salas, unidentified objects were observed hovering over Minuteman intercontinental ballistic missile silos at the same time that the missiles experienced sudden electronic failures, rendering them temporarily incapable of launch. Similar incidents were reported at other strategic missile facilities, including Walker Air Force Base in New Mexico and Loring Air Force Base in Maine. The official explanations offered varied across incidents, but several of the witnesses involved have stated publicly that the explanations provided were inconsistent with what they observed. The implications of these reports, if accurate, are significant. They suggest that unidentified objects were not only present in restricted airspace, but were demonstrating capabilities that affected the operational status of nuclear weapon systems. Blue Book also examined cases involving multiple independent witnesses across geographically separated locations. In 1966, a series of sightings in Michigan involving dozens of witnesses, including police officers and civilians, prompted congressional attention and led to a formal investigation by the astronomer J. Allen Hynek. Hynek had served as a scientific consultant to Project Sign, Project Grudge, and Project Blue Book throughout their operations. Initially, he had been skeptical of the phenomenon and had often produced the conventional explanations that the program used to dismiss cases. Over the course of his 17 years of involvement, however, his views shifted. He had personally examined thousands of reports and had found that a substantial fraction could not be explained through conventional means. His handling of the Michigan case, in which he attributed the observations to swamp gas, became widely criticized and is sometimes cited as a turning point in his thinking. After Blue Book closed in 1969, Hynek founded the Center for UFO Studies and spent the remainder of his career advocating for serious scientific investigation of the phenomenon. Blue Book was officially terminated in December of 1969 following the publication of the Condon Report, a study commissioned by the Air Force and conducted at the University of Colorado under the direction of physicist Edward Condon. The Condon Report concluded that further study of unidentified flying objects could not be justified scientifically, and the Air Force used this conclusion to justify ending its public investigation program. The report was controversial within the scientific community, with critics arguing that its conclusions did not actually follow from the evidence it had examined. Of the cases the Condon team analyzed, roughly 30% remained unexplained, which by most standards would justify continued investigation rather than termination. Furthermore, internal documents that emerged after the report's publication suggested that the program's director had stated his intended conclusions before the investigation began, raising serious questions about its impartiality. When Blue Book closed, the official position of the United States Air Force was that no evidence had been found to suggest that unidentified flying objects represented a threat to national security, that they were technologically beyond the capability of known terrestrial science, or that they were extraterrestrial in origin. This position has remained the official line for more than 5 decades, even as new information has emerged suggesting that the picture was more complex than the public closure of Blue Book indicated. Multiple sources, including former intelligence officers, have since indicated that classified investigations continued under different program names and within different agencies after Blue Book's termination. The public investigation had ended, but the phenomenon had not, and neither, apparently, had government interest in it. The Blue Book records were eventually transferred to the National Archives and are now publicly accessible. Researchers who have spent years examining the files have noted both the breadth of the collection and its limitations. The collection contains thousands of credible reports from military and civilian witnesses, supported in many cases by radar data, photographs, and physical evidence. It also contains many cases that were closed with explanations that do not fully fit the underlying observations, suggesting that the program's analytical standards were sometimes shaped more by institutional pressure than by the evidence itself. What the collection does not contain is the most significant information that the United States government was collecting on the phenomenon during the same period. That information, according to multiple disclosures that would eventually reach the public, was being handled through separate channels with different classification protocols and was never intended to be released through the Blue Book archive at all. Yet this evidence raises new scientific questions because if the public investigation was incomplete, the private investigation must have continued, and the question of what that private investigation found would not be addressed publicly for nearly half a century after Blue Book closed its doors. On December 16th of 2017, an article appeared on the front page of the New York Times that fundamentally changed the conversation about unidentified aerial phenomena. The article, co-authored by reporters Helene Cooper, Ralph Blumenthal, and Leslie Keane, revealed the existence of a previously undisclosed Pentagon program called the Advanced Aviation Threat Identification Program, sometimes abbreviated as AATIP. The program had operated from 2007 to 2012 with an annual budget of approximately $22 million, drawn from the so-called black money portion of the defense budget that is not publicly itemized. Its purpose, according to the documents and sources cited in the article, was to investigate reports of unidentified aerial phenomena encountered by United States military personnel, with particular attention to incidents that involved observable performance characteristics inconsistent with known aerospace technology. The existence of AATIP was a revelation for several reasons. It demonstrated that the official position of the Department of Defense regarding unidentified phenomena, which since the closure of Project Blue Book in 1969 had been that the government took no interest in the subject, was incomplete. It also indicated that the program had been investigating specific incidents involving credible military witnesses, instrumented data, and sensor recordings, which placed the investigation on substantially different footing than the largely anecdotal reports that had characterized Blue Book. And perhaps most significantly, the article was accompanied by the release of 3 video recordings that had been captured by United States Navy aircraft and that depicted objects exhibiting flight characteristics that defied conventional aerodynamic explanation. The 3 videos, which would become known by the names Tic Tac, Gimbal, and Go Fast, had been authenticated through internal Department of Defense channels and were eventually formally released by the Pentagon in April of 2020. The Pentagon's release did not endorse any particular interpretation of what the videos showed, but it confirmed that the recordings were genuine, that they had been captured by Navy sensors during operational flights, and that the objects depicted remained officially unidentified. This confirmation was important. In the past, similar video recordings had circulated in civilian channels, but could always be dismissed as either fabrications or as misidentifications of known phenomena. The Pentagon's authentication removed those possibilities. Whatever was in the videos, it was not a hoax, and the Department of Defense itself had been unable to explain what it was. The man at the center of the AATIP disclosure was Luis Elizondo, a former intelligence officer who had served as the program's director from 2010 to 2017. Elizondo had resigned from the Department of Defense in October of 2017, citing what he described as institutional resistance to taking the phenomenon seriously and to addressing what he believed were potential national security implications. In his resignation letter, addressed to the Secretary of Defense, Elizondo argued that the program had collected evidence of objects demonstrating capabilities that exceeded any known terrestrial aerospace technology, and that the failure to investigate these objects further represented a significant intelligence gap. After his resignation, Elizondo began speaking publicly about his work, providing detailed accounts of the program's findings and its operating procedures. Elizondo's account was supported and amplified by other former officials, including Christopher Mellon, who had served as Deputy Assistant Secretary of Defense for Intelligence under both the Clinton and the second Bush administrations. Mellon was a senior figure within the defense and intelligence community whose credentials were essentially impossible to dismiss. His decision to speak publicly about unidentified aerial phenomena lent significant credibility to the disclosures, and he became one of the most articulate advocates for further investigation. Mellon wrote opinion pieces for major newspapers, testified before legislative bodies, and gave interviews in which he stated that the United States military had collected substantial evidence of objects in restricted airspace whose origin and capabilities could not be explained. The disclosures triggered by the 2017 New York Times article were not entirely without precedent, but they were qualitatively different from anything that had come before. Previous official acknowledgments of unidentified phenomena had typically been limited, hedged, and quickly walked back. The 2017 disclosures, by contrast, involved named officials, declassified documents, authenticated video footage, and sustained engagement with the subject by major news organizations. The Times article was followed by additional reporting in other outlets, by congressional briefings, by hearings before the Senate Intelligence Committee, and eventually by legislative requirements that the Department of Defense produce formal reports on the subject. The momentum of the disclosures, once started, did not stop. In June of 2021, the Office of the Director of National Intelligence delivered a preliminary assessment to Congress titled Preliminary Assessment: Unidentified Aerial Phenomena. The report examined 144 incidents reported by United States military personnel between 2004 and 2021. Of these, the report stated that only one could be explained with high confidence, and the explanation in that single case was that the object was probably a large balloon of unknown origin. The remaining 143 cases were classified as unidentified, meaning that the available data was insufficient to determine what the objects were. The report acknowledged that some of the objects appeared to have demonstrated unusual flight characteristics. including high acceleration without apparent propulsion, sudden changes of direction, and operations across a range of altitudes from sea level to high atmosphere. The report did not endorse any particular hypothesis about the origin of the objects, but it explicitly identified extraterrestrial origin as one of the possibilities that could not be ruled out, alongside hostile foreign technology, classified United States programs unknown to the investigators, atmospheric phenomena, and other unspecified causes. The preliminary assessment was a significant document for several reasons. It was the first time in the modern era that an official United States intelligence product had publicly acknowledged that some unidentified phenomena could not be explained by known means. It was also the first time that such a document had been delivered to Congress and made available to the public rather than remaining classified within intelligence channels. And it established a precedent for ongoing reporting requirements, which would lead to additional and more detailed reports in subsequent years. In July of 2022, the Department of Defense established a successor program called the All-Domain Anomaly Resolution Office, sometimes abbreviated as ARO. ARO was placed within the Office of the Undersecretary of Defense for Intelligence and Security and was given a broader mandate than its predecessors. The new office was tasked with investigating unidentified phenomena across all domains, including air, sea, space, and what the establishing documentation called transmedium operations, meaning objects that transition between different domains, such as moving directly from air to water or vice versa. The inclusion of transmedium operations was particularly notable because it indirectly acknowledged that some of the phenomena being investigated involved observed behaviors that crossed conventional environmental boundaries in ways that no known terrestrial vehicles can replicate. The establishment of ARO was accompanied by additional legislative provisions that strengthened reporting requirements, protected whistleblowers from retaliation, and created mechanisms for personnel with relevant information to come forward without jeopardizing their careers. These provisions were significant because they recognized implicitly that information about unidentified phenomena had been compartmentalized within various agencies and programs in ways that made comprehensive analysis difficult. The whistleblower protections in particular suggested that legislators expected additional disclosures to follow, and that those disclosures might involve personnel who had been operating under non-disclosure agreements or within highly restricted classification levels. The pattern of these disclosures over a period of roughly 7 years, from 2017 to 2024, was unusual. Government policy on unidentified phenomena had been remarkably stable for decades, with the official position remaining essentially unchanged from the closure of Project Blue Book through the late 2010s. The shift after 2017 was not a single event, but a sustained reorientation of how the United States government engaged with the topic. Multiple agencies began producing reports, multiple committees began holding hearings, multiple officials began speaking publicly, and the legal framework for investigating and disclosing relevant information was substantially updated. Whatever was driving this shift, it was not the result of a single decision, but appeared to reflect a broader change in institutional posture. Various explanations have been offered for why this shift occurred when it did. Some have suggested that the proliferation of smartphones and high-resolution cameras had made it increasingly difficult to maintain the previous policy of denial, because civilian recordings of unexplained phenomena were becoming common and were being analyzed by independent researchers. Others have suggested that the development of advanced sensor systems aboard military aircraft had produced new categories of evidence that could not be dismissed as easily as anecdotal reports, forcing the institutional position to evolve. Still, others have suggested that the geopolitical context, including concerns about advanced foreign aerospace programs and the desire to ensure that the United States was not falling behind in some critical area of technology, had created pressure for more open investigation. None of these explanations is mutually exclusive, and all of them probably played some role in the changing institutional environment. What is clear is that by the early 2020s, the question of unidentified aerial phenomena had moved from the margins of public discourse into the mainstream of national security policy. Senators were holding hearings, generals were testifying, intelligence officers were giving named interviews to major news organizations, and the videos that had been declassified and released were being analyzed by aerospace engineers, physicists, and military analysts, all of whom were attempting to determine what the recorded objects might be and what their capabilities implied for our understanding of physics, technology, and the broader question of who or what was operating in our skies. Yet this evidence raises new scientific questions because the videos themselves were only the visible portion of a much larger body of data, and the most consequential analyses focused on incidents that combined visual recordings with radar tracks, infrared signatures, and pilot eyewitness accounts that together described objects whose performance characteristics resisted every available explanation. The story of the Advanced Aerospace Threat Identification Program began not in a Pentagon office, but in a private conversation between a United States senator and a Nevada-based aerospace entrepreneur. The senator was Harry Reid of Nevada, who at the time was the Senate Majority Leader and one of the most powerful figures in American politics. The entrepreneur was Robert Bigelow, the founder of Bigelow Aerospace and Budget Suites of America, who had been a longtime advocate for serious investigation of unidentified phenomena. The two men had known each other for years, and they had discussed at various points the possibility that the federal government should take a more systematic interest in incidents involving anomalous aerial objects, particularly those reported by military personnel during sensitive operations. By the mid-2000s, Reid had become convinced that the topic warranted official attention, and he began working with two other senators, Daniel Inouye of Hawaii and Ted Stevens of Alaska, to establish a small program within the Department of Defense that could examine the phenomenon without becoming a target of public ridicule or political opposition. The program that resulted from these discussions, AATIP, was structured deliberately to avoid attention. Its budget was modest by Pentagon standards, its existence was not publicly acknowledged, and its activities were classified at levels that limited access to a small number of cleared personnel. The program was housed within the Defense Intelligence Agency and operated under contracts with private aerospace firms, including a contract with Bigelow Aerospace that supported much of the technical analysis. The contracting arrangement was unusual but not unprecedented. The Department of Defense routinely uses private contractors for specialized analysis, and the structure allowed the program to draw on expertise that was not available within the government itself. The work conducted under AATIP focused on a relatively narrow set of incidents that met specific criteria. The program was particularly interested in cases that involved multiple sensor confirmations, credible military witnesses, and observed flight characteristics that could not be explained by known aerospace technology. The most thoroughly documented of these incidents, and the case that would eventually become the public face of the program, occurred in November of 2004 off the coast of Southern California. The incident is now known as the Nimitz Tic Tac encounter, named after the aircraft carrier whose strike group was conducting training operations in the area, and after the shape of the object that was observed. The Nimitz encounter unfolded over the course of approximately 2 weeks, with multiple radar contacts being made by ships and aircraft assigned to the strike group. The advanced AN/SPY-1 radar systems on board the cruiser USS Princeton detected unusual objects appearing at altitudes of approximately 80,000 feet, then descending rapidly to near sea level in periods of seconds. The descent rates implied by the radar data were physically impossible for any known aircraft, exceeding the structural limits of any conventional airframe and producing acceleration profiles that would be lethal to any human pilot. The radar operators initially suspected that their equipment was malfunctioning, but the contacts persisted across multiple shifts and were eventually confirmed through cross-referencing with other sensor systems within the strike group. The pattern was consistent. Objects appeared at high altitude, descended at impossible rates, hovered briefly at low altitude, then either disappeared or returned to high altitude. On November 14th of 2004, the Princeton was tracking one of these objects when an FA-18F Super Hornet from Strike Fighter Squadron 41, operating from the Nimitz, was vectored to the location for a visual identification. The aircraft was crewed by Commander David Fravor, the commanding officer of the squadron, and his weapons systems officer. A second FA-18F, crewed by Lieutenant Commander Alex Dietrich and her weapons systems officer, was also on station. The 4 aviators arrived at the location specified by the Princeton's radar and observed an unusual disturbance in the surface of the ocean below them. The water appeared to be churning in a circular pattern, as if something just beneath the surface was causing it to agitate, though there was no visible object in the water itself. Above this disturbance, at approximately 15,000 feet, a white object was hovering. Fravor would later describe it as resembling a Tic Tac mint, smooth, white, and approximately 40 feet in length, with no visible wings, propulsion systems, control surfaces, or windows. Fravor descended toward the object to investigate, and the object began to move. It did not move in any pattern that the pilots had previously encountered. It accelerated in directions that seemed to bear no relation to any aerodynamic profile, performing maneuvers that appeared to involve abrupt changes of velocity without any visible means of generating thrust. As Fravor continued his approach, the object suddenly accelerated away at a speed that he later described as exceeding anything he had seen during his career as a Navy fighter pilot. Within seconds, the object was gone. The Princeton's radar then detected the object reappearing at the so-called Combat Air Patrol Point, which was a location approximately 60 miles away that had been established earlier as a coordination point for the strike group's aircraft. The reappearance was almost instantaneous from the perspective of the radar operators. The object had traveled 60 miles in less time than the radar's refresh cycle. The Tic Tac encounter is significant for several reasons. The witnesses were all experienced Navy aviators with extensive flight time and credibility. The observations were made simultaneously from multiple platforms, including the Princeton's radar, the aircraft involved in the intercept, and other supporting elements of the strike group. The observed flight characteristics included sustained high-altitude operations, near instantaneous transitions between widely separated locations, hovering without apparent propulsion, and rapid acceleration that exceeded the performance of any known aircraft. Furthermore, the encounter was captured on the infrared targeting sensors of one of the FA-18Fs, producing a video recording that would later become one of the 3 videos released by the Department of Defense. The video shows a small thermal signature in the center of the frame, moving against the background in ways that the pilot's narration confirms as unusual. When the Nimitz returned to port and the aviators submitted their reports, they expected significant follow-up from intelligence personnel. According to Fravor's later testimony, no formal debrief occurred. The reports were filed, but no one from the broader intelligence community appeared to investigate the incident in the depth that the aviators believed it warranted. This pattern of incomplete institutional response to high-quality reports is one of the recurring themes in the history of unidentified phenomena, and it would become a central concern in the years following the disclosures. The data from the Nimitz encounter eventually made its way into the AATIP archive, where it was analyzed in considerable detail. The program's technical evaluations attempted to determine whether the observed flight characteristics could be reconciled with any known aerospace technology, including classified American programs, foreign aerospace developments, or natural phenomena. The conclusions of these evaluations, as summarized in subsequent disclosures, were that the observed performance characteristics exceeded anything that could be explained through conventional means. The objects appeared to be operating under principles of propulsion and inertial management that were not consistent with any technology known to exist or to be in development by any government or private entity. The Nimitz encounter was not unique. Similar incidents had been recorded by Navy aircraft in other operational areas, particularly along the east coast of the United States, in the 2014 to 2015 timeframe. Pilots from the USS Theodore Roosevelt and other carrier groups reported numerous encounters with unidentified objects during training exercises off the Atlantic coast. These objects exhibited similar characteristics to those reported off California, including high-altitude operations, rapid acceleration, and apparent disregard for conventional aerodynamic principles. The frequency of these encounters became significant enough that the Navy formally revised its reporting procedures in 2019, establishing a streamlined process for aviators to report unidentified phenomena without facing the institutional skepticism that had previously discouraged such reports. The two videos that accompanied the Tic Tac footage in the public releases were captured during these East Coast encounters. The gimbal video, recorded in January of 2015, shows an oblong object moving against high-altitude winds while rotating around its central axis. The audio captured during the recording includes the voices of the Navy aviators commenting on the unusual flight characteristics of the object, with one pilot remarking on the apparent presence of a fleet of similar objects in the area. The Go Fast video, also from 2015, shows a smaller object moving rapidly across the surface of the ocean, with the targeting system having difficulty maintaining a lock on the rapidly moving target. The pilots in this video also comment on the unusual nature of the object's motion. Each of these videos has been subjected to extensive technical analysis by both government investigators and independent researchers. The analyses have attempted to determine the actual flight characteristics of the objects shown, accounting for the motion of the recording aircraft, the orientation of the targeting sensors, and the apparent parallax effects that can sometimes produce misleading impressions of velocity. The results of these analyses have been mixed. Some researchers have argued that the apparent motion of the objects can be partially explained by sensor artifacts and aircraft motion. Others have argued that even after such effects are accounted for, the residual motion of the objects remains inconsistent with any known aerospace platform. The debate over the precise interpretation of the videos continues, but what is not in dispute is that the videos are authentic recordings of objects that the Department of Defense itself has classified as unidentified. The combination of the Nimitz encounter, the East Coast incidents, and the various other cases documented by AATIP produced a body of evidence that was qualitatively different from what had been available during the era of Project Blue Book. Where Blue Book had relied primarily on eyewitness reports supported by occasional radar data, AATIP had access to multiple high-resolution sensor systems operating simultaneously across different platforms. The data could be cross-referenced, validated, and analyzed in ways that had not been possible during earlier investigations. And the conclusions that emerged from these analyses, while never publicly endorsing any particular hypothesis about the origin of the objects, made clear that the phenomena being observed could not be dismissed through conventional explanations. Yet, this evidence raises new scientific questions because the convergence of multiple sensor systems on objects whose flight characteristics exceeded the capabilities of any known technology pointed toward something that demanded explanation, and explanation required confronting possibilities that the scientific establishment had been reluctant to examine for most of the 20th century. The technical analyses of the Tic Tac, Gimbal, and Go Fast videos drew sustained attention from physicists and aerospace engineers in the years following their release. The discussions that emerged were not primarily about whether the videos showed something unusual, since the Department of Defense had already authenticated them and labeled the objects as unidentified. The discussions centered instead on what physical principles would have to be operating for the observed flight characteristics to be possible, and whether any plausible terrestrial technology could explain those characteristics. The Tic Tac video, captured by the ANSQ-228 Advanced Targeting Forward-Looking Infrared System mounted on Commander Chad Underwood's FA-18F, shows a small thermal signature against a relatively featureless background. The object appears as a bright white shape on the infrared imagery, indicating that it was significantly warmer than its surroundings. The pilot's commentary, recorded as part of the cockpit audio, includes observations about the object's apparent maneuverability and the difficulty of maintaining a sensor lock on it. The video itself is short, lasting only about a minute and a half, but the broader incident from which it was excerpted involved sustained observations over a longer period and across multiple sensor platforms. The gimbal video is perhaps the most discussed of the three releases. It shows a dark oblong object surrounded by what appears to be a halo or rotating cloud, moving against high-altitude winds at speeds that the pilots verbally estimate to be unusual. One aviator in the recording can be heard saying that the object is going against the wind, with the wind in the region recorded at approximately 120 knots. The object also appears to rotate around its vertical axis during the recording, an action that has been the subject of considerable debate. Some analysts have suggested that the apparent rotation is an artifact of the targeting system's gimbal mechanism, which adjusts its orientation as the aircraft maneuvers, while others have argued that the rotation appears to be a genuine property of the object itself, particularly given the consistency of the rotation with the audio commentary from the pilots. The full interpretation of the gimbal video remains contested, but the basic facts of its origin and authenticity are not. The Go Fast video, the shortest and most ambiguous of the three, shows a small object moving rapidly across the surface of the ocean. The targeting system tracks the object with difficulty, and the pilot's commentary expresses surprise at the object's apparent speed and its proximity to the water surface. Subsequent analyses of the Go Fast video have suggested that the apparent speed of the object may have been exaggerated by the geometric relationship between the aircraft and the object, with parallax effects making the object appear to move more rapidly than it actually was. According to some interpretations, the object in the Go Fast video may have been moving at speeds consistent with a balloon or a slow-moving aerial vehicle, and the appearance of rapid motion was an artifact of the recording geometry. Other analysts have rejected this interpretation, arguing that even after parallax effects are accounted for, the residual motion of the object remains anomalous. What makes these three videos collectively significant is not any single feature of any one recording, but the convergence of multiple independent sensor systems on objects that share certain characteristics. The objects do not appear to have visible propulsion systems. They do not have the wing or control surface configurations of conventional aircraft. They operate across a wide range of altitudes, from sea level to the upper atmosphere. They exhibit acceleration profiles that, if accurate, exceed the structural limits of any known aerospace platform. And they appear in operational areas of the United States Navy with sufficient frequency that the Navy formally updated its reporting procedures in 2019 to streamline the process by which aviators could document such encounters. The principle of sensor convergence is central to the analysis of these incidents. A single sensor producing anomalous data can usually be attributed to a malfunction, a calibration error, or an unusual environmental condition. Two sensors of different types showing the same anomaly raise more difficult questions. Three or more sensors, particularly when supported by human eyewitness reports, become extremely difficult to dismiss through conventional explanations. The Nimitz incident, in particular, involved the simultaneous detection of objects by the AN-SPY-1 radar aboard the Princeton, the AN-APG-73 radar aboard the FA-18F aircraft, the AN-ASQ-228 infrared targeting system, and the visual observation of the pilots themselves. The convergence of these independent systems on the same objects, with consistent reports of unusual flight characteristics, eliminates the most common alternative explanations. When sensor convergence cannot be dismissed, the question shifts to what kind of object could produce the observed signatures. Aerospace engineers have approached this question from multiple angles. One angle is to compare the observed flight characteristics with the limits of known propulsion systems. Conventional jet engines, the most efficient form of aerial propulsion currently in widespread use, are limited by the speed of sound and the structural constraints of the aircraft they propel. Rockets can exceed these limits but require massive fuel loads and produce visible exhaust plumes. Neither type of propulsion can produce the kind of rapid acceleration and abrupt direction changes that have been reported in some of the Navy encounters. Another angle is to consider hypothetical propulsion technologies that have been discussed in the theoretical literature but have never been implemented. The concept of metric engineering, sometimes called spacetime engineering, has been explored in academic physics journals for several decades. The idea is that if the geometry of spacetime itself could be manipulated, a vehicle could, in principle, move through space without obeying the inertial constraints that apply to conventional matter. The mathematical basis for such manipulation is grounded in general relativity, which permits solutions to its field equations that describe configurations of spacetime allowing rapid transit. The most discussed of these is the Alcubierre drive, proposed by the Mexican physicist Miguel Alcubierre in 1994. The Alcubierre drive does not violate the speed of light constraint of special relativity, but it permits effective faster-than-light travel by contracting spacetime in front of a vehicle and expanding it behind. The energy requirements for actually constructing such a drive, however, are astronomical, and the theoretical work has remained largely speculative. A related concept involves the manipulation of inertia itself. In conventional physics, the mass of an object resists changes in its motion, requiring force to accelerate it. If a technology existed that could effectively reduce or eliminate the inertial mass of an object while preserving its gravitational mass, it would be possible to accelerate the object using minimal force. Some theoretical work has explored whether such manipulation might be possible through interactions with the quantum vacuum or through other exotic mechanisms, but no experimental confirmation has ever been obtained. If such a technology existed and were applied to a vehicle, the flight characteristics that would result would be remarkably similar to those reported in the Navy encounters. An object with effectively zero inertia could accelerate, decelerate, and change direction without the limitations that constrain conventional aircraft, and it would not require visible propulsion systems to do so. The connection between these theoretical concepts and the observed characteristics of the unidentified objects is not direct evidence that the objects are using such technologies. The connection is suggestive, but not conclusive. What the connection establishes is that the observed flight characteristics, while inconsistent with any known technology, are not necessarily inconsistent with physics itself. There are theoretical frameworks within which such characteristics could in principle be achieved, even if humanity does not currently possess the engineering capability to realize them. This distinction is important because it shifts the question from whether the observations are physically possible to whether they are achievable by a sufficiently advanced civilization. The question of what counts as a sufficiently advanced civilization brings the discussion back to the Fermi Paradox. If interstellar travel is physically possible, even through exotic means that require advanced understanding of physics, then the absence of evidence for extraterrestrial civilizations becomes more difficult to explain through assertions of impossibility. If interstellar travel is not possible, then any objects observed in our atmosphere must have terrestrial origins, even if their performance characteristics exceed our current capabilities. The convergence of sensor data on objects exhibiting characteristics consistent with theoretical exotic propulsion is therefore relevant to both questions simultaneously. Beyond the propulsion question, there are additional aspects of the observed phenomena that deserve attention. Some of the objects have reportedly been observed transitioning between air and water without slowing down, a behavior known in the technical literature as transmedium operation. Conventional aerospace vehicles cannot perform such transitions because the structural and propulsion requirements for atmospheric flight and underwater operation are fundamentally different. An aircraft entering water at high speed would be destroyed by the impact, and a submarine breaching the surface would be subject to enormous structural stress. The fact that transmedium operations have been reported, including in incidents documented by AARO, suggests that whatever is producing these phenomena is not constrained by the design principles that govern human engineering. There have also been reports of objects exhibiting what might be called signature management characteristics, meaning that they appear to selectively present themselves to different sensor types. Some objects have been observed visually, but not on radar. Others have appeared on radar, but not on visual observation. Still, others have appeared on infrared sensors, but not on visual or radar. The selectivity of these appearances has led some analysts to suggest that the objects may be capable of actively controlling their detectability across different parts of the electromagnetic spectrum, a capability that would represent an extraordinary advance over any known stealth technology. Whether this interpretation is correct remains contested, but the pattern of selective detectability is itself a feature of the data that requires explanation. The aggregate picture that emerges from these analyses is that the unidentified phenomena being investigated by AATIP and its successor programs are not adequately explained by any known terrestrial technology, and that their observed characteristics are consistent with what would be expected from a technology operating on physical principles beyond current human engineering capability. This does not by itself establish that the objects are of extraterrestrial origin. There are alternative explanations, including the possibility that they are products of classified programs unknown to the investigators, or that they are exotic atmospheric phenomena that have not yet been characterized scientifically, or that they are some combination of these and other factors. But the evidence does establish that the conventional categories of explanation are insufficient, and that the investigation of the phenomena requires consideration of possibilities that have historically been excluded from serious scientific discussion. Yet this evidence raises new scientific questions because the investigation of possibilities beyond conventional explanation has not been confined to the analysis of sensor data alone, but has extended into the realm of formal congressional testimony, where individuals with extensive intelligence and military backgrounds have made claims under oath that, if accurate, would transform the discussion of unidentified phenomena from one of capability to one of provenance. On July 26th of 2023, a hearing was convened by the House Oversight Subcommittee on National Security, the Border, and Foreign Affairs. The hearing was titled Unidentified Anomalous Phenomena: Implications on National Security, Public Safety, and Government Transparency. It was the most substantive public hearing on the subject of unidentified aerial phenomena ever held by the United States Congress, and the testimony delivered during it transformed the public conversation about what the government knew when it had known it and what it had chosen not to disclose. 3 witnesses testified that day, each with backgrounds that made it impossible to dismiss them as speculative or unreliable. Their names were Ryan Graves, David Fravor, and David Grusch, and the cumulative weight of their statements created a new framework for evaluating what the disclosures of the previous several years actually meant. Ryan Graves was the first witness. He was a former United States Navy lieutenant who had served as an FA-18F pilot in Strike Fighter Squadron 11, operating from the USS Theodore Roosevelt during the 2014 to 2015 period when the East Coast encounters became frequent. Graves described how the encounters had become routine for his squadron during their training operations off the Atlantic coast. He testified that pilots in his unit were regularly observing unidentified objects in restricted airspace, that these objects exhibited flight characteristics inconsistent with any known aircraft, and that the institutional response to their reports had been to discourage formal documentation. He stated that pilots feared the impact on their careers if they reported what they were seeing, and that the lack of a formal reporting mechanism meant that many encounters were never documented at all. Graves had since founded an organization called Americans for Safe Aerospace, which advocates for systematic investigation of unidentified phenomena and provides support for current and former military personnel who wish to report their own encounters. David Fravor was the second witness. He was the commander of Strike Fighter Squadron 41 during the 2004 Nimitz encounter, and his testimony provided a detailed account of what he had observed on November 14th of 2004. Fravor described the Tic Tac object in measured and technical language, presenting it as a professional debriefing rather than a sensational account. He stated that the object had exhibited capabilities that exceeded any known aerospace platform, that the observations had been confirmed by multiple sensor systems, and that the institutional response to his squadron's report had been minimal. He noted that no formal debrief had been conducted, that the data had been collected and filed, but not investigated in the depth that the incident warranted, and that the subsequent 2 decades had not produced any explanation from the government regarding what he and his crew had encountered. Fravor's testimony was particularly significant because his credibility as a senior naval aviator and combat veteran was essentially unassailable. He had nothing to gain from fabricating his account and considerable potential to lose, and his measured presentation reinforced the seriousness of what he was describing. The third witness, however, delivered the most consequential testimony of the hearing. David Grusch was a former intelligence officer who had served 14 years in the United States Air Force and the National Geospatial Intelligence Agency. He had held high-level security clearances and had been involved in classified programs related to space and aerospace matters. From 2019 to 2021, he had served as the National Reconnaissance Office's representative to the Unidentified Aerial Phenomena Task Force, which was the precursor program to ARO. In that role, he had been responsible for collecting and analyzing information about unidentified phenomena from across the intelligence community. In 2022, he had filed a formal complaint with the Inspector General of the intelligence community, alleging that information about unidentified phenomena was being withheld from Congress in violation of statutory requirements. The Inspector General had reviewed his complaint and found it to be both credible and urgent, allowing Grusch to make protected disclosures to congressional committees. In his testimony before the House subcommittee, Grusch made statements that, if accurate, fundamentally altered the framework for understanding the phenomenon. He stated that he had been informed through his official duties of a long-running program within the United States government to recover and analyze non-human craft and biological materials of non-human origin. He stated that this program had been operating for decades, that it had been compartmentalized in ways that prevented oversight by the appropriate congressional committees, and that the information collected by the program had been withheld from elected officials with legitimate authority to receive it. Grusch was careful to clarify that he was not personally testifying that he had seen non-human craft or materials. He was testifying that he had been provided information about the existence of such materials by individuals with direct knowledge, that he had assessed those individuals to be credible, and that he had referred the information to the Inspector General and to congressional oversight committees through appropriate classified channels. The specific claims Grusch made under oath included assertions that the United States possessed craft of non-human origin, that biological materials described as non-human biologics had been recovered from some of these craft, and that elements of the program responsible for their retrieval and analysis had been illegally privatized through contracts with aerospace and defense corporations. He stated that he had provided detailed evidence supporting these claims to the Inspector General and to closed congressional sessions, and that the public testimony he was offering was a redacted version of more comprehensive information that he had submitted through classified channels. The Department of Defense issued a statement following the hearing that disputed Grusch's claims. ARO's official position was that it had found no verifiable evidence of any program to retrieve, analyze, or reverse engineer non-human craft, and that no credible evidence had been provided to support the existence of such a program. The Pentagon's position has remained consistent in subsequent reports and statements. Grusch and his supporters have maintained that the denials reflect the same compartmentalization that produced the original complaint, and that the relevant information has not been provided to AARO or to other oversight bodies because access to it is restricted at classification levels above those held by the personnel conducting the investigations. The conflict between Grusch's testimony and the Department of Defense's denials placed congressional investigators in a difficult position. The witness was a credentialed intelligence officer who had filed his complaint through formal channels and had been determined to be credible by the intelligence community Inspector General. The Department of Defense, on the other hand, was an institutional respondent with both the authority and the apparent will to deny the existence of the programs Grusch described. The resolution of the conflict required information that could not be made public, and the congressional committees with the appropriate clearances were left to evaluate the competing claims based on classified evidence that the rest of the country could not see. In November of 2024, a second hearing was held by a different House subcommittee, this time involving testimony from additional witnesses. The new witnesses included Luis Elizondo, the former director of AATIP, Michael Gold, a former NASA official, Tim Gallaudet, a retired Rear Admiral and former NOAA administrator, and Michael Schellenberger, an investigative journalist who had been reporting on the topic. Their testimony reinforced many of the themes that had emerged in the July 2023 hearing adding additional details and additional names to the picture that was forming. Gallaudet's testimony was particularly notable because of his background. As a retired flag officer with extensive experience in oceanographic and atmospheric science, he had no apparent reason to engage with the topic of unidentified phenomena, except through direct exposure to the data. He stated that during his career, he had encountered information about unidentified phenomena that he believed warranted serious scientific investigation, and that the institutional culture had discouraged such investigation in ways that he found deeply troubling. He spoke about specific incidents involving Navy assets in proximity to unidentified objects, and he advocated for a more open scientific approach to the data. Elizondo's testimony added detail to claims he had been making publicly since his resignation in 2017. He described internal resistance within the Department of Defense to taking the phenomenon seriously, instances of what he characterized as the deliberate suppression of evidence, and the existence of compartmentalized programs that he believed had collected substantial data on unidentified phenomena over many decades. His statements echoed the broader picture that Grusch had presented, with both former officials describing an institutional environment in which information about the phenomenon was being managed in ways that prevented appropriate oversight and analysis. The cumulative impact of the 2023 and 2024 hearings was substantial. They established a formal congressional record of sworn testimony from credentialed witnesses describing the existence of programs that had not been publicly acknowledged. They created pressure for additional disclosure and additional oversight. They produced legislative proposals, including provisions in subsequent defense authorization bills, that attempted to mandate the release of additional information and to strengthen the protections available to whistleblowers in the intelligence community. And they shifted the public conversation in ways that were unlikely to be reversed. What the hearings did not produce was direct evidence in the form of physical materials, declassified imagery beyond what had already been released, or unambiguous documentation of the programs described by the witnesses. The claims made under oath were detailed and specific, but they remained claims, subject to verification through processes that have not yet been completed. The Department of Defense's denials, while disputed, remained the official position. The resolution of the conflicting accounts will require either additional disclosures, additional investigations, or some combination of both. Until those resolutions occur, the public will remain in the position of evaluating sworn testimony from credible witnesses against institutional denials from agencies that, by the witnesses' own accounts, may not have full access to the information they are denying. There is a particular feature of the testimony that deserves additional attention. Grusch's claims about non-human biologics, if accurate, would extend the implications of the disclosures from the realm of advanced technology into the realm of biology. The technology, however exotic, can be described in terms that relate to physics and engineering. The biology, however, raises a different category of questions. If biological materials of non-human origin have been recovered, then the question of what those materials are, where they came from, and what they imply about the origin and prevalence of life elsewhere in the universe becomes immediate. The materials, if they exist, would represent the first direct physical evidence of life beyond Earth, and their analysis would address questions that astrobiology has been pursuing through indirect means for decades. Yet this evidence raises new scientific questions because the analysis of any such materials would require methods and standards that go beyond the analysis of conventional manufactured artifacts, and the questions raised by such an analysis would extend far beyond the technological capabilities of whoever or whatever produced them. The question of whether physical materials of non-terrestrial origin exist in the possession of any government contractor or private entity is among the most consequential questions that could possibly be asked. If the answer is yes, then nearly every assumption about humanity's place in the universe must be revised. If the answer is no, then the testimony provided to Congress by credentialed officials represents either a fundamental misunderstanding on their part or a deliberate deception, neither of which is easy to reconcile with the credibility of the individuals involved. The question is not new. Claims of recovered materials have circulated for decades, dating back to the Roswell incident of 1947 and continuing through various subsequent reports of recoveries in different locations. What is new is the institutional framing of the claims, with sworn testimony before Congress replacing the anecdotal accounts that previously characterized the discussion. Before examining the specific claims regarding non-terrestrial materials, it is useful to consider what such materials would actually have to demonstrate to be considered evidence of non-terrestrial origin. The standard for proof of extraterrestrial provenance is high, and it is high for good reasons. Terrestrial chemistry and metallurgy have produced an enormous variety of materials over the course of human technological development, and the boundaries of what can be manufactured on Earth continue to expand with advances in materials science. A material that appears unusual at first examination may turn out to be the product of a classified manufacturing process, an experimental alloy, or some other terrestrial origin that was not initially apparent. To be considered evidence of non-terrestrial origin, a material would need to exhibit characteristics that fall outside the range of what is possible to produce on Earth, even with the most advanced known manufacturing techniques. One category of such characteristics involves isotopic composition. Every element on the periodic table exists in multiple isotopic forms, distinguished by the number of neutrons in their atomic nuclei. The ratio of isotopes in any given sample is determined by the conditions under which the material was formed, and these ratios are highly characteristic of their origin. Materials formed in different stellar environments, in different planetary settings, or through different chemical processes will have different isotopic signatures. On Earth, the isotopic ratios of common elements have been measured with extreme precision over many decades, and the natural ranges of variation are well documented. A material with isotopic ratios significantly outside the terrestrial range would be strong evidence of non-terrestrial origin, because it would indicate formation under conditions that do not exist on Earth. This is the standard that has been applied to certain materials that have been put forward as candidates for non-terrestrial provenance. The most discussed of these materials is a sample sometimes referred to as the Arts Parts, named after the radio host Art Bell, to whom the material was originally sent anonymously in the 1990s. The sample consists of layered metallic fragments, with the layers composed primarily of magnesium and other elements in unusual ratios. Analysis of the sample has been conducted by various researchers over the years, with the most prominent recent work being performed under the auspices of investigator Gary Nolan, a professor of pathology at Stanford University, who has applied advanced isotopic analysis techniques to materials of potential non-terrestrial origin. Nolan's work, conducted in collaboration with various other researchers, has involved the application of high-resolution mass spectrometry to samples that have been alleged to be of non-terrestrial origin. The technique he has used is capable of measuring isotopic ratios with extreme precision, well beyond the capabilities of conventional analytical methods. His findings, reported in various interviews and presentations, have been that some of the samples examined exhibit isotopic ratios outside the normal terrestrial range. He has been careful in his public statements to clarify the limits of what these findings prove. Anomalous isotopic ratios do not by themselves establish non-terrestrial origin, because they could in principle result from undocumented terrestrial processes. What they do establish is that the samples are unusual, that their composition is not consistent with the most common manufacturing or natural processes on Earth, and that further investigation is warranted. The interpretation of these findings remains contested within the scientific community. Some researchers have argued that the isotopic anomalies, while real, do not necessarily indicate non-terrestrial origin, and that they could result from specialized industrial processes that produce unusual isotopic ratios as byproducts. Other researchers have argued that the magnitude of the deviations is too large to be explained through any known terrestrial process, and that the most parsimonious explanation is that the materials originated outside of Earth. The debate is ongoing, and its resolution will depend on additional analyses, including, ideally, the application of the same techniques to additional samples, and the publication of detailed methodological papers that can be subjected to peer review. Beyond the specific question of isotopic composition, there are other characteristics that have been claimed for some of the alleged recovered materials. These include structural properties that are difficult to reproduce, such as the layered metallic configurations of the arts parts samples, thermal properties that are inconsistent with the elemental composition, and electromagnetic properties that produce unusual responses to external fields. Each of these properties, if confirmed through rigorous analysis, would add to the case that the materials are unusual. None of them, by themselves, would constitute proof of non-terrestrial origin, but their cumulative weight could shift the assessment toward such a conclusion. The challenge with all of this analysis is that the materials being examined have not been provided with documented chains of custody linking them to specific incidents involving unidentified phenomena. Most of the samples that have been examined arrived through anonymous channels, were submitted by individuals who claim to have obtained them through various means, or were drawn from collections assembled by researchers over many years. The lack of documented provenance limits the conclusions that can be drawn even from rigorous analytical work, because there is no way to verify that the materials originated from where they were claimed to have originated. This is a fundamental limitation of all civilian research on the topic, and it is one of the reasons why the testimony of officials with access to government held materials, if such materials exist, would be so significant. The claims made by David Grusch in his congressional testimony regarding non-human biologics are even more difficult to evaluate in the absence of physical evidence. Biological materials, unlike metallic samples, degrade over time and require specific preservation methods to maintain their integrity. The analysis of biological materials of potential non-terrestrial origin would require the application of techniques drawn from biochemistry, genetics, and molecular biology, in addition to the techniques that have been applied to non-biological samples. Such analysis, if conducted, would presumably be among the most carefully controlled scientific investigations ever performed, given the implications of the results. The phrase non-human biologics, as Grusch used it in his testimony, is itself ambiguous. It could refer to organic materials of confirmed non-terrestrial origin, meaning materials whose biochemistry is fundamentally different from that of any known Earth life. It could refer to materials of uncertain origin that have not been positively identified as belonging to any known species. It could refer to bodies or body parts of beings whose physical characteristics differ from those of any known Earth organism. The specific meaning of the phrase has not been clarified in any public statement, and the underlying claims have not been supported with publicly available evidence. What is on the public record is the assertion made under oath by an individual with the credentials and clearances to make such an assertion meaningful. The implications of confirmed non-human biological materials would extend far beyond the immediate question of unidentified phenomena. If such materials existed and could be analyzed, they would provide direct evidence about the chemistry of life beyond Earth, the prevalence of various biochemical strategies in the universe, and the relationship between life as we know it and life as it might exist elsewhere. The questions that astrobiology has been pursuing through indirect means for decades, including the question of whether life is based on the same fundamental chemistry everywhere, or whether it explores fundamentally different solutions in different environments, could be addressed directly through such analyses. The contrast between the potential significance of such findings and the current state of public knowledge is stark. If the materials exist, as Grusch claims, then they represent the most important scientific specimens ever collected. If they do not exist, then the testimony before Congress represents either a profound misunderstanding or a deliberate fabrication by a credentialed officer, with no apparent motive for either. The available public evidence does not allow a definitive resolution of this question. What it does establish is that the question itself is being taken seriously by elements of the United States government, that legislation is being introduced to mandate further disclosure, and that the institutional barriers to addressing the question are being slowly eroded through a combination of legal action, journalistic investigation, and political pressure. The methodology that would be required to evaluate any such materials, if they were made available, has been developed extensively over the past several decades through the analysis of extraterrestrial materials whose origin is not in dispute. Meteorites, lunar samples returned by the Apollo missions and subsequent robotic missions, and dust grains returned from comets by missions such as Stardust have all been subjected to detailed analysis, and the techniques developed for their study would be directly applicable to materials of more controversial provenance. Mass spectrometry, electron microscopy, neutron activation analysis, X-ray crystallography, and various other methods can characterize materials at levels of detail far beyond what is required to distinguish terrestrial from non-terrestrial origin in principle. The combination of these capabilities with the materials described in the testimony, if they exist and were made available, would produce conclusions that could not be reasonably disputed. This is one of the central tensions in the current state of the field. The technical means exist to evaluate the claims definitively, but the materials necessary to apply those technical means remain inaccessible to the scientific community. The bottleneck is institutional rather than scientific, and its resolution will require either disclosure by those who hold the materials or the emergence of new materials through other channels. In the meantime, the work that can be done with civilian samples continues. Gary Nolan and his collaborators have published peer-reviewed papers on various aspects of their analytical work, and they have established research programs at Stanford and at other institutions to systematically examine materials of potentially anomalous origin. Other researchers have pursued parallel investigations, and the development of standardized methodologies for handling and analyzing such samples is gradually taking shape. The field is moving from one in which individual researchers operated in isolation to one in which a recognizable scientific community is beginning to form around the systematic study of anomalous materials. Whether this community will eventually have access to the materials described in congressional testimony remains to be seen. The political and legal pressures pushing toward disclosure are real and growing, but the institutional resistance is also real and well established. The outcome of this tension over the coming years will shape the trajectory of the field for decades to come, and it will determine whether the questions raised by the testimony are answered through additional disclosure or through the gradual accumulation of evidence from other sources. Yet this evidence raises new scientific questions, because the question of whether such materials exist is only the beginning of a much larger inquiry. And that larger inquiry must eventually return to the framework that has organized the discussion of extraterrestrial intelligence since the middle of the 20th century, asking whether the silence of the universe is best explained by emptiness, by distance, or by mechanisms operating to prevent contact between civilizations that may not be as separated as the silence suggests.